Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथरे मु ऑलरेडी प्लस 2 सेकंड ईयर सिलेबस कंप्लीट कर सारछि एबे मु प्लस 3 CBCS ऑनलाइन क्लासेस रो वीडियोज गुडा अपलोड करिवि जदि भल लागिला ताले लाइक कर देबो एवं सब्सक्राइब कर देबो जो वीडियोज गुडा मु अपलोड करिवि तार नोटिफिकेशन पई एठी बेल आइकन को ऑल रे सेट कर देबो गोटे इंपोर्टेंट जिंस वीडियोज रो ऊपर एठी जो 3 डॉट्स देखुछो तार क्वालिटी एठी देखो बाय डिफॉल्ट 360 अछि तमे ताकू पढे मध्ये परिबो एठी एडवांस रे क्लिक करी तमे रिजोल्यूशन बढ़े परिबो प्रति वीडियोज रे मु पीडीएफ लिंक देबी ताकू एठी ड्रॉप डाउन लिस्ट रो तमे क्लिक करी डाउनलोड मध्ये करि परिबो पीडीएफ को लास्ट रे एठी जो मोर चैनल नेम अछि याकू क्लिक करी तमे एठी प्ले लिस्ट को जाई मु प्रति वीडियोज को यूनिट वाइज एज पर सिलेबस सजाई की रखिथिबी तमे सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज रो टॉपिक रे हमें मास एनर्जी रिलेशन विषय रे पढिबा व्हिच इज आल्सो नोन एज Einstein's mass energy equivalence E equal to mc square, which is a very famous relation. So this is one of the most revolutionary concepts in the history of science, and it can be used for converting the mass into energy and vice versa. So a concept ro quantitative description को आमे derive करि परिबा in form of a relation which is your E equal to mc square, known as the mass energy relation. So for this, let us use the Newton's second law of motion, according to which the force is the rate of change of momentum. So F equal to d by dt of mv. एठी m को जदि आमे relativistic mass कहिला, then its value is as per the special theory of relativity m equal to m0 by square root of 1 minus v square by c square हुए. So ताकू एबे आमे put कर देला. Accordingly force रो value आसीगला this much. Now let us say the kinetic energy of the body is capital T, then its rate of change is equivalent to your power, which is the product of force and velocity. So force रो जो एई value टा हमें पाइथिला ताकू हमें एई जगह रे पुट करिबा. Now we operate this differentiation. Okay, so एठी देखो ऊपरे velocity अछि आ तळे एई जो square root रो term, accordingly differentiation एई दुईटा term ऊपरे apply हेबो. Okay, one by one. So first velocity v ऊपर अप्लाई हैला, देन एटी स्क्वायर रूट रो टर्म ऊपर अप्लाई हिची. ओके, सो याकू आमे जदी याकू सॉल्व करी करी जिबा, देन फाइनली वी विल गेट अ रिलेशन लाइक दिस d by dt of m0 c square by 1 minus v square by c square to the power half. ओके, अच्छा तापरे याकू आमे इंटीग्रेट करिबा. एटा जो आसिला एटा वैल्यूटा कोन d by dt of capital T. ओके, याकू एबे आमे इंटीग्रेट करिबा. देन अपॉन इंटीग्रेशन सपोज एठी आमे गोटे कांस्टेंट नेगला स्मॉल k व्हिच इज द कांस्टेंट ऑफ इंटीग्रेशन. ताले ए स्मॉल k रो वैल्यू आमे आकू बाहर करिबा. ओके, सो दिस इज नथिंग बट योर kinetic energy T, which is equal to m0 c square by 1 minus v square by c square to the power half, or simply square root of 1 minus v square by c square. Okay, plus k. Now we choose the constant, which is the constant of integration small k, in such a way that the classical theory is also satisfied. देखो classical theory माने आमे बुझिबा at v equal to 0 the kinetic energy will be equal to 0. That means putting this value in the above equation we will get small k to be equal to minus m0 c square. Okay, ताको एबे सब्स्टिट्यूट करिबा ऊपर रिलेशन रे, then t equal to this much. एठी m0 by square root जो ए टर्म टा आसुची, this is your relativistic mass m, so simply t equal to mc square minus m0 c square or m minus m0 into c square. ए जो आमे देखुछु m minus m0 ए टर्म को आमे सपोज कहला डेल्टा m. ओके, व्हिच इज द इंक्रीज इन मास, बिकॉज आमे जानि छु रेस्ट मास टा जो तार वैल्यू थाए ताठू तमरो रिलेटिविस्टिक मास रो वैल्यू टा बेसी रही थाए. सो m minus m0 obviously it will be positive, so delta m is the increase in mass of the body due to the increase in its kinetic energy. Okay, thus the increase in mass is associated with the increase in energy, and here m0 c square eta hochi rest energy. tome jani cho rest energy of a material body, and it is assumed to be possessed by the body at rest. So total energy capital E যদি কইবা এই বডির ইয়ার ভ্যালুটা কেতে হব, it should be the sum of the total rest energy and kinetic energy. So T plus m0 c square, T ର ଭ୍ୟାଲୁ ଆମେ ଏତିକି ପାଇଛୁ, ୟାକୁ ପୁଟ୍ କରିଦେଲା, ଏଠି ଦେଖ ଏଇ ଦୁଇଟା ଟର୍ମ କ୍ୟାନସେଲ୍ ଆଉଟ୍ ହେଇଯିବ. So that finally ଆମେ ପାଇଲା E equal to mc square, which is the Einstein's mass energy relation. Okay, and here m is the relativistic mass of the body, and this equation, the Einstein's mass energy relation, states a universal equivalence between the mass and energy, and this result unifies the two distinct classical principles of conservation of energy and convertibility of one form of energy into another. আমি জানিছো energy can never be created nor be destroyed, it can only be converted from one form to another. So ତାକୁ ବି ଇଏ fulfill କଲା. Okay, now this equation relates the energy to every mass and relates the mass to every energy, and this is true for any kind of energy. Maybe সেটা potential energy ହେଇପାରେ কিংবা kinetic energy ହେଇପାରେ কিংবা electromagnetic energy ହେଇପାରେ. Okay, यार physical significance এই जो mass energy relation रो যদি ଆମେ ଦେଖିବା, the relation E equal to mc square, which is expressing the mass and energy, actually it is the equivalence between these two, and it is the most important result of special theory of relativity. And this relation shows that under suitable condition mass can be converted into energy and vice versa, ଯେମିତି ଆମେ starting ରେ କହୁଥିଲା. Okay, classical Newtonian mechanics ଯଦି ଦେଖିବା, ସେଥିରେ there are two separate conservation laws. First ହେଲା the law of conservation of mass, second one is the law of conservation of energy. तापरे ये जो आइंस्टाइन्स मास एनर्जी रिलेशनशिप जो आमे बाहर कला इन स्पेशल थ्योरी ऑफ रिलेटिविटी, ये दुईटा को ये कंबाइन कर देला, ऊपर भी सही जिनिस आमे पढुतला जो. ओके, सो इट कंबाइन्स दीज टू लॉज इनटू वन. ओके, इट यूनिफाइज देम, दैट इज द लॉ ऑफ conservation of mass and energy. Okay, now in nuclear phenomenon in which the energy is released, there is a corresponding decrease in the total mass, and in such phenomenon in which the energy is absorbed, there will be an equivalent increase in mass. Okay, so energy jodi release hochi tale mass decrease koruchi, energy jodi absorbed hochi tale mass madhya increase hochi. But as the velocity of light in free space is very large, its value is c, which is 3 into 10 to the power 8 meter per second, a very small decrease in mass will result in a release of very large amount of energy, because relation ही हमारा यही भलिया E equal to mc square and the value of your c is very high. तेणु अल्प mass decrease हेले मध्य बहुत large amount of energy release हेबो. Okay, for example जदि आमे conversion देखिबा, rest mass 1 atomic mass unit, that is around 1.65 into 10 to the power minus 27 kg. This is a very small quantity, but it is releasing 931 MeV of energy. Okay, because of this factor c square present in the mass energy relation. Okay, supporting nuclear phenomenon, then एठी कहूची देखो फर्स्ट पॉइंट रे कहला nuclear phenomenon like your fission, माने nuclear fission and nuclear fusion are very important examples of conversion of mass into energy, and they are most popular in the present day methods for production of energy. Then second point रे कहूची mass energy relationship help us to determine the binding energy of various nuclei on the basis of mass defect. Okay, mass defect माने जो delta m जदि आमे mass defect कहला, this into c square will be your binding energy, एटा आमे जानिछु. Okay, then third point रे कहूची the energy released in an annihilation of matter, that is annihilation of suppose electron positron pair, then it also supports the mass energy relationship. Okay, so annihilation of matter रे भी ये mass energy relationship को support करूची. So this is all about your mass energy relation. Thank you.